Hey guys, so today we're going to go over volume and surface area of pyramids and cones. Last time we went over surface area and volume of prisms and cylinders. Now these are going to be very similar, except these are basically what you think a little bit smaller versions. Now they're a little bit more intense in certain areas because of what we're going to have to do to find things to help us solve for them. But again, if you're following the formulas and recognize certain things that used to come in that we learned about beforehand, it'll be a little bit easier. All right. So looking at pyramids to start, you'll notice that a pyramid looks very much partly like a prism, except that instead of ending in two bases, it has one base and ends at a point. You guys remember the Great Pyramids of Giza? That's basically how we got the name. So the volume of a pyramid is exactly like the volume of a prism, except it's one third of a prism with the same height. Um, B is still the area of the base, and we're talking the base polygon. So in this case, it's a square pyramid over here. If we're doing triangular or pentagonal or hexagonal, we're pretty much going to stick to regular pyramids. We're not going to do any really odd shaped pyramids. So everything's going to be regular. So if you remember your area of regular polygons, the 1/2 AP from beforehand, you'll need it for this. And then, of course, H is the height. Now, you'll look on the diagram here, and we see that H is already kind of drawn in for us. Now, when we're looking at the height is always drawn from the apex to the dead center of whatever base we're talking to, or talking about, or looking at. Now, that helps us do one thing in that that's the height, straight up and down. It's like if you drop a string, it'll go straight down to the middle. What you see over here on the other side, right? This one going from the apex down the side of the pyramid and is perpendicular to the side at its midpoint. Well, that is what we call the slant height. That is my L, and that comes into play when we especially are looking for surface area. So let's look at the surface area formula. It's surface area is equal to the area of the base, because it only has one, not two like beforehand, plus 1/2 the perimeter times L. Now, if you think about it, guys, all these sides, this PL, this lateral area, this 1/2 PL, well, these are all right. These are all triangles. So how do you find the area of a triangle? Well, it's 1/2 the height of the triangle times the length of the side the height is perpendicular to. So in this case, the sides that it's perpendicular to are the perimeter of the base, and then the slant height, which is the height of every triangle. So that's where the 1/2 PL comes from. Area of the base, P the perimeter of the base, right? Perimeter of the base, and the slant height. And what you'll notice here is that if you connect the slant height with the regular height, right? And I'll redo these real quickly. Slant height with the regular height, that it creates a right triangle. So we have our height, we have the slant height, right? And then if we drew them together along the base, it creates a nice right triangle. And that's going to come important. So you got to remember your right triangle trig, or your right triangle, how to solve for it, like Pythagorean theorem or 30, 60, 90, or 45, 45, 90. All those come into play. All right. Looking at cones are basically the same thing, guys, but instead of B, we're going to be using pi r squared because it's a circle. And then the height still remains the same. It's still the straight up and down from the vertex or the apex of the cone to the center of the circle or center of the base. And then the slant height in this case is basically that like edge of the cone, the one that slants all the way down to the edge. And then, of course, if you look at that, if you connect the radius, which is what we need for everything, the radius is like that connector there. There's our R radius. It creates that right triangle. So basically, guys, a cone, in all reality, how to form a cone is if you took a right triangle and you spun it around along one of its legs. Basically, the leg just stays put, and you just spin the rest of it around and around and around. It creates a cone. And that's how they basically form a cone. So the area of the base, again, is that pi r squared. There's my area, my base. There's my B. And the height is up and down. And then we're looking at surface area. Well, it's one base. There's my B. And then pi RL, which is pi times radius times the slant height. And again, I'll label slant height over here as L. The slant height And how we get pi r L is, well, guys, if you think about it, it's 1/2 PL, what's 1/2. The perimeter of the base, which is 2 pi r, because it's a circle, times the slant height, which is L. And then if you take half of 1/2 of 2 is just pi r L. So there's where that pi r L comes from. So there's where the 1/2 PL. So the formulas are the same. It's just when we start dealing with circles, it's pi r squared, pi r, 2 pi r, all that good stuff. All right, so let's look at a few examples here. We're going to go with a basic pyramid and a basic cone. We'll start with a pyramid here. All right, so when we're looking at pyramids, right, we need a few things. We need the base, we need the height, we need the perimeter, and we need the slant height. And those are things we need now. Now, some of this we already know. We know that the height is 3, and that's easy. It's already there. We know that the length of one side of this pyramid is 8 inches, so every side is 8 inches. So if you think about it, that's the perimeter is going to be 32, 4 times 8. And the base is, since it's a square pyramid, again, we're assuming these are all regular square, it will be 8 squared, so that's going to be 64. So the only thing we have to really solve for is my slant height. So we need to solve for this right here, my slant height. Now, it's not going to be a perfect drawing. Slant height. So I'm going to go ahead and create my right triangle out of this just so I can figure this out. Now, remember what I told you about the height? The height always drops in the middle. Now, I know it doesn't look like it on the drawing, but it always drops to the dead center. So if you think about it, if the whole side length here is 8, then half of that's going to be 4, which is going to make it very easy to solve because now we have a right triangle to solve for L. There's my L. So if you think about it, it's 3 squared plus 4 squared equals L squared. 9 plus 16 equals L squared. 25 equals L squared. We're using Pythagorean theorem here, guys. And so L equals 5. So now we can do all our formulas now because we have all the necessary information. All right, so surface area, here we go. We need the area of the base, 64, plus 1/2 the perimeter, which is 32, times the slant height, which is 5. So it's basically going to give me 64 plus 1/2 of 32 is 16. 16 times 5 is 80. And so I'm left with 144. We're dealing in inches squared. All right, so volume. Volume is 1/3 the area of my base, which is 64, times my height, which is 3. Well, 1/2, 64 times 1/3 of 3 is just 64. There's 1 and then times 64, 64. So we're left with 64 inches cubed. Makes that calculation a little bit easier. If we're looking for exact value, guys, leave fractions. Again, don't do decimals unless otherwise told. And if you're asked around the nearest hundredth, then your calculator can come into play in a lot of these things. But this one would end up being 64 straight. You didn't even need to calculate for it. All right. So looking at the next one, the cone. Well, in the cone, we need certain things. We need R, we need H, and we need L. Those are the only 3 things. Now, R is already given to us at 6. H is given to us at 8. The only thing we have to find here is L. Now, again, right triangle. Boom, boom, boom. There's my right triangle. So if you think about it, guys, Pythagorean theorem, I'm looking for my hypotenuse. So 6 squared plus 8 squared equals L squared. 36 plus 64 equals L squared. 100 equals L squared. Square root that, and we get L is 10. All right, so now we can do our formulas here. All right, so for surface area, it's pi times R squared, so 6 squared, plus pi times the radius, which is 6, times L, which is 10. So that gives me 36 pi plus 6 times 10 is 60 pi. So that gives me 96 pi, and we're dealing in inches squared. And that's an exact value, so leave it like that. No reason to calculate pi at this moment, but if we do, use the one on the calculator. Use the calculator pi button. All right, so volume is 1/3 pi times the radius squared, so 6 squared times the height, which is 8. So I'm going to kind of do this in my head. I'm not going to write all this out, but 6 squared is 36. 36 divided by 3 is 12. 12 times 8 is 96. And so we end up with 96 pi. And that's inches cubed. Now, I know you're thinking, well, wait a minute, volume and surface area are the same? Number-wise, yes, but they're different units, so they're not exactly. So don't even think of them that way. But just be aware that that's what's going on. All right, so now a little bit more complicated. Now we have these compound figures. And this takes a little bit of looking. Now, if you look at the first figure, this is a polyhedron we introduced back when I introduced solids. This is a tetrahedron, and it's created by all equilateral triangles. So if we're looking at this, all sides, no matter what side we're looking at, or edge here, they're all the same. They're all sixes. So they're all equilateral triangles. Now, I'm still going to write down the same things we need. B, H, L, and all that good stuff for base, height, L, and we need perimeter as well. Now, a couple of these things we can find. One thing we can find out real quickly. Since this is 6, we know that everything has to be 6, which means this is 6, this is 6, this is 6, this is 6. So if we look at this as a pyramid on top of a pyramid, because that's what it is, a square pyramid on top of a square pyramid, then the perimeter of that pyramid, or the base, is going to be 6 times 4, which is 24. I'm going to kind of get the easy one out of the way, because the rest of it's going to take a little bit of figuring out. Because right now, we don't know the height. We don't know the area. We can find the area of the base because it's 6 by 6, so that's 36. That's going to be an easy one. We don't know the height. We don't know the slant height. So we got to find both of those. Now, that's going to be a little bit trickier, so I'm going to kind of draw these in real quickly. If we look at the height would go directly down to the middle. Boom, right there in the middle of the base. And then the slant height is going to travel along the edge. Now, it's not going to be 6 because that is the edge right there. That is not actually down the middle. And then, of course, we have that. Now, one thing we do know is that this part right here, right there, the halfway for the base, because I told you to talk in a minute, that's going to be 3. So I'm going to kind of draw down here. I'm going to redo this a little bit. And we know that this part here is 3. Now you're saying, okay, wait a minute. We still can't find one side, and no angles don't help us. So what I'm going to do real quickly is I'm going to draw the equilateral triangle out here, and I'm going to show you why I can get all this real quickly. If we know these are all equilateral triangles, and each side of this is 6, right? Now, if you look at the slant height, it's kind of hard to see, but if you look at the slant height, it drops right down the middle of one of these equilateral triangles, right? So it cuts it in half, which means this is 3, that's 3, and then there's my height. Well, guys, if you remember, equilateral triangles, all the angles are congruent, right? Which means each angle here is 60 degrees, which means the angle up here that gets cut in half has to be 30. And guess what that brings in? Yep, 30, 60, 90 right triangles. So if you remember your ratios, that's x root 3, and 2x. And the side I gave you, well, it's the hypotenuse. It's 6. We know that the short side is going to be opposite of that, which is 3, which we already kind of figured out since that height. And then so the h here, my slant height, in this case L, is going to be 3 root 3. So I've already figured out L. So I have L. I have the 3. So this is now 3 root 3. I'm sorry. That's not right there. I wrote it in the wrong spot. L is 3 root 3. Let me redraw my triangle here. That part's 3. That's L, which is now 3 root 3. And we need to figure out H. Well, guess what? Right triangle Pythagorean theorem, here we go. 3 squared plus h squared equals 3 root 3 squared. So that's going to give me 9 plus h squared equals 3 root 3 squared. 3 squared is 9. Root 3 squared is 3. So 9 times 3 is 27. So that leaves me with h squared equals 18. And if I square root that on both sides, h is equal to 3 root 2. All right, so now I have everything I need to figure out the rest of my problems. All right, now surface area here is a little bit different. Now, since these are all equilateral triangles, there's a shortcut way than doing all the b plus p 1/2 PL, because all we need is 1/2 PL, but we got to double it, so it'd just be PL. We can do that, and it's going to give you the same answer. So normally we do b plus 1/2 PL, right? But since the base is covered up, it's not on the surface. That gets ignored. And then 1/2 PL would only take the top half. And since they're double of them, we're going to double this by 2. So it's really just going to be PL, which in this case is going to be 24 times 3 root 3. Now, 24 times 3 is going to be 72 root 3. Now, there's another way to do this. If you remember way back, a few lessons ago, like I was telling you about the area of regular polygons, that the area of a equilateral triangle is equal to the square root of 3 over 4 times the side squared, right? So if we did that, square root of 3 over 4 times 6 squared, well, that would give me 9 root 3. And if you took 9 root 3 and you multiply it by how many equilateral triangles you have in here, and if you counted them up, that's 8. Well, 8 times 9 is 72 root 3. Pretty cool that they come out to be the same thing, regardless of which way you do it. So that's just a way of thinking about the tetrahedrons, centimeters squared. A couple ways you could have done it. If you like the other way. What the good way about what I did beforehand was it gives me everything for my volume. Now my volume, well, normally for a regular pyramid, so one normal pyramid, is that it's 1/3 the base, which is 36, times my height, which would have been 3 root 2. And then since there's not just one pyramid, there's 2 pyramids. And I have no clue why it did it that way. Pen likes me sometimes and doesn't like me the other times. All right, so here's what we're going to do. Let's start simplifying things. 1/3 and 36, that's 12. So now it's 2 times 12 times 3. Well, 3 times 12 is 36 times 2 is 72. So this ends up being 72 root 2. And then that's going to be centimeters cubed. Just a weird coincidence that the 72 is the same. All right. Now for this last one. Now this is one you're going to have your calculator with you because we have some decimals involved. So I want you to use your calculator. Now I'm going to tell you a couple things when we do this, but just follow along. All right. So we have a cylinder and we have a cone, and the cone is on top of the cylinder. This is called a silo question. Usually if you flip this upside down, it looks like a silo. If you don't know what one is, go to a farm or something. Those are where they store all the grain and stuff. So given this, a couple things we need. Since they are cylinders and cones, right, we need certain things. For my cylinder, right, We need the radius, which is 5. And we need the height, which in this case is 17.8. For my cone, I need the radius, which again is 5. Doesn't change. I need my height, which is 6.2. And then I need my slant height, which in this case is 8. So now I can do that to find my surface area and volume. Now, what we'll notice here is that for my surface area, we kind of want to combine both a cone and the cylinder. However, you'll notice that both the cylinder and cone, a base, and I'm shading it in here, the base down here, is covered up. It's not on the surface. It's inside the figure. So normally with a cylinder, the surface area is 2b plus ph, right? Except there's only one base showing, so it's only 1b, or in this case, pi r squared. And of course, the pen just doesn't want to like me right now. So we get pi r squared plus 2 pi r h. For the cone, normally we would have b plus 1/2 pl. Well, again, that b is no longer there, so we really only have 1/2 pl. So if I convert it to the pi r's, it would be just pi r l, and that's all we need. So if you think about it, guys, we're only going to use pi r squared plus 2 pi r h and the pi r l for my surface area. So looking at surface area here, it's going to be pi times 5 squared plus 2 pi 5 times the height of the cylinder, which is 8, plus, now we'll do the cone part, pi times 5 times my slant height, which is 8. So if we put all that together, that is 25 pi plus 5 times 17.8 times 2, that's 178 pi. 5 times 2 is 10, times 17.8 is 178 pi, plus 40 pi. And so if you add all those together, 25 plus 178 plus 40, you end up with 243 pi. And we're dealing in centimeters squared. So that right there is my exact value. And if we did the decimal to it by multiplying pi, that would give you 763.41. And now again, I don't round till the very end. So this is the 243 pi is what I would plug into my calculator to get that. All right, volume is going to be a little bit trickier in that we need the volume of both the cylinder and the cone, and we're going to add them together. The volume doesn't rely on what's exposed. It's just what you can fill up. So I'm going to start with the cylinder. So that is pi. And if you remember, it's pi r. So I'm going to do volume over here. That's pi r squared h. And then for a cone, it's 1/3 of that. 1/3 pi r squared h. So pi times 5 squared times h, which is 17.8. There's my volume of my cylinder. Plus 1/3 pi times 5 squared again times the 6.2 now. I'm going to change colors just so I can be able to read it with the purples here. All right, so that gives me 25 times 17.8, and that's going to give me 445 pi for my cylinder, plus 25 times 6.2, which is 155 over 3. So that's 155 over 3 pi. Now, if I was looking for exact value, that would be fine, or I can do 445 times 3 and then add the 155. And it's not, so it'd be 1490. I mean, I'm going to put it over here in a little red, near, a weird color. Let's see. Let's try orange. Oh, let's do that. That would end up being 1,490 pi over 3 as a non-decimal. That would be one answer. If I do it together, that's 496.6 repeating times pi. And so if I do that as a final value, and I'll put that in green, we get a final rough estimate of 1,560.32. And again, I don't plug in pi until the very end after I've already calculated all the numbers together. So 445 plus 155 divided by 3, you add those together, then multiply that value by pi. You can do that on your calculator. You literally just said once you get those two numbers added together, you just hit times second pi, and then that's what your answer is. All right, so when you get the compound figures a little bit, it's divide and conquer. And the biggest problem is when you're doing surface area, know what's covered up. We'll do a little bit more of this especially when we get into spheres and hemispheres, because we like to do little silos or snow cones with the hemispheres. And that does matter what's there, what you're seeing. So just keep that in mind when we're doing this. This is a good one. And make sure you do your homework, and I will see you next class.